Awesome. So those are some limitations to exponential growth. Real quick, what I want you to do is just write what happened in that video. Write either how you felt when you saw those numbers, what happened with those numbers. Do you think that's actually going to happen? Okay. So it was called the human population video. Human population video. So what happened in the human population video? How did you feel about it? Could it actually really happen? We're going to call it the human population video. It's kind of like if humans were that bacteria we saw in the first video and kept on multiplying, 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 and then just never stopped.
Crazy.
Yep. Okay, can one person share what they wrote? Dylan, is that a volunteer?
No.
Can you share what you wrote? So what happened in the human population video?
Everything is multiplied. Nobody would die.
Okay. Okay, make sure that's on your paper. Okay, so exponential growth in cells. You should know that this happens in cells because what did y'all come from? A blank and a blank. A sperm and an egg. How many cells is that? How many cells are you? You are a lot of cells. Okay, so basically, a sperm with half of your chromosomes has to fertilize an egg with half of your chromosomes. You get a fertilized cell, and that cell needs to do what Corey said is grow and divide. And those two cells will grow and divide. Then those four cells will grow and divide. So ready? You start with one cell. It grows, it divides. Now it looks exactly like that initial cell. These cells grow and divide. So if we wanted to solve a problem, like for example, embryonic cells divide in 60 minutes, okay, so that's their generation cycle. How long will it take to get over 100 cells? Now, the science way, the way that we might do it would be, okay, start with 1, you get 2 in the second generation. Then you get 4, then you get 6, and we kind of do it by paper, kind of multiplying. Now, there has to be an easier way to do this. Because what if I would have said, when do we get 1,000? Are we just going to keep on going on our piece of paper and times it by 2, times it by 2? There has to be a formula, okay? So there has to be an easier way to calculate growth as opposed to just multiply again and again and again. Okay, so this right here is the exponential growth model formula. This will tell us what the growth rate of something is. So what I want everybody to do is write down y equals c, parentheses, 1 plus r to the t. And write down what all of those letters mean. Okay, so what do all of those mean? So y is your amount. C is how much you start with. Okay, now 1 plus R is going to be your percent increase. That would be like the cells increased by 100%. Okay, so that's where we're going to figure out our percent increase. What we need to do is we need to say 1 plus whatever the rate is. So it's 1 plus R is the rate. And then T is just your time period. How many years was your, was it in your problem? Okay? So this is your time. Okay, now with this formula, you can figure out a lot of things. So everybody look up here. I can say, how many, I don't know, give me an example, cows will you get if you start with 5 they increase 200% every year over 20 years. Okay, so whatever your problem tells you, you can factor all this stuff in. Or you can say something like, if you have 100 cows, they multiply twice a year, and they've been multiplying for 5 years, how many did you start with? Okay, so you can manipulate this formula to solve for any of those variables. Okay, so we're going to try that now real quick. Okay, now this is an example. You don't have to copy it down. So, growth rate, we mostly see this in the economy in your bank account. This is something that you could calculate. It's something that you should, because you can see, which accounts can give you more interest. Okay, so you deposit $500 in an account that pays 8% annually interest compounded yearly. What is the account balance after 6 years? Okay, so you put 500 in there, don't touch it for 6 years. So this solution is actually, before we substitute it into the formula, this is when we would find it out per 1 year, multiply the rate by 2 years, multiply the rate by 3 years, all the way up to 6 years. Okay, but if we would just substitute it in to our handy dandy formula, we'll get that answer real quick. So, what is our end amount when we start with $500? So we start with C, $500. The rate is 8%. So that's when we put the 0.08 here, and we have it in the bank for 6 years. Okay? Once you do that on your calculator, you get $793. Okay? So all we did was we took all of our unknowns, substituted them in, and we got our end answer. Okay? Okay, this is the problem we're going to do. We're going to calculate the growth rate of rabbits. We're going to graph it. Okay? So, a population of 20 rabbits is released into a wildlife region. The population triples each year for 5 years. Okay, you don't have to copy down this now. First thing you want to do is calculate the growth rate. Now, if it triples every year, it means that the growth rate has to be 3. So this in here has to be 3. And it's actually doubling at a rate of 200%. So before we substitute anything in, I just want to show you what the growth rate is. Okay, so the population triples each year. The growth factor has to be a total of 3. That means it's the 1 plus the rate of growth, which is 200%. Okay. So what I want y'all to do is copy down this problem here. We're going to work this problem out. So what is the population after 5 years? We start with 20 rabbits. Population triples each year. Our 5 years. So our population started off with 20. Okay. Triples each year. And then T, of course, is per time. Now, if we want to do it for 5 years, we started off with 20. Triples it each year. Over 5 years. This is our end answer. So what I'm going to have you do is copy this down now. But on the next slide, we're actually going to look at the growth every year. So I'm going to give, I'll pair y'all up. Y'all can do this formula for year 1, 2, 3, 4, or 5. So after you copy this down, Corey and Ronnie, y'all are going to figure out the population for 0 years. Dylan and Philip, you're going to calculate the population for 1 year. Greg and Andy, you're going to do 2 years. Stephen and Megan, where are we at? 3 years, 4 years, 5 years. So technically, okay, so once this is copied down, calculate the growth rate of the year that I just told you. I'm going to move on to the next slide. Y'all are going to put it up on the board. So we got 0, 1, 2, 3, 4, 5. Yep, right down.
It was fast. You may just do it again.